In example 7, we're asked to solve each equation and state our answer in terms of common logarithms and then use a calculator to find the approximate value to the nearest hundredth. So we're looking for both the exact value here and then also we're going to get an approximate value. If we look at this equation on the left hand side, there's the variable in the exponent position and it's not on the right hand side. So we can do what we did for the previous example in 6 and just go ahead and change this into a logarithmic equation. So this is log base 5 of 73 equal to 4x. To solve for x, we just need to divide everything by 4. We could write this as log of 73 over log of 5, and then the 4 would be down here in the denominator. This would be our exact answer for x. In terms of common logarithms, remember common logarithms have a base of 10 and we usually don't write them. If you want to evaluate this in your calculator, we can evaluate this as log of 73 divided by, and if you're going to do this all in one step, you've got to do an extra set of parentheses, log of 5, and we'll close both of those. We'll hit enter and we get about 0.66, and the number to the right of the second 6 is also a 6. So we'll round the 6 up to a 7. So x will be approximately 0.67. We could check this in the calculator real easily. Just do 5, raise it to the 4 times your answer, and see what you get. Get 73, and we can look that the right side is 73 as well. So we're good to go with this answer. We need to provide both in this case. Here's the exact value, and then this one right here is going to be your approximate. Note that even though you're dividing these logs, you can't just write this as one logarithm and divide these two together. It just doesn't work like that. If you were subtracting log 73 and log 5, then you could go ahead and write that as log 73 over 5, but this is the simplest form we can get to. If we look at this one on the right hand side, we're going to have to do something a little bit different. You can notice here that there's an x in the exponent position on the left and also in the exponent position on the right. So if we try to rewrite this as a logarithm, it's not going to help out too much. What we can do though is we can take the logarithm of each side, and when we do that, we'll be able to move these exponents out in front of the logarithm, one of our power rule for logarithms. So we can write this as 4x times log of 6, and this one we need to use parentheses, 3x plus 1 times the log of 36. If we distribute this log of 36 all the way across, and remember that the log of 36 is just some value, and you can treat it as such. Like if this was a 4 out here, you would just distribute the 4. You can do the same thing with logarithms. So this one, I'm going to change this a little bit. I'm going to make this x times 4 log 6. It's really the same thing. We're just multiplying everything together. And this one's going to be x times 3 log 36 plus log 36 if we do that distribution. We have an x on the left and an x on the right. We want to group those x's together. So we could subtract x times 3 log 36 from this side, and x and 3 log 36. So this should be 3 log 36 from the left side. So this will be x times 4 log 6 minus 3 log 36, there's an x there, equal to log of 36. We can factor this x out. We'll have 4 log of 6 minus 3 log of 36, and that's equal to log of 36. Remember that this is just one value, it's just one number, so just like if you had maybe 4x is equal to 12, you would divide by whatever this coefficient here is of x, and we can do the same thing here. So x will be log of 36 over 4 log of 6 minus 3 log of 36. This is our exact value. If you wanted to, you could take this 4, put that inside and raise 6 to the 4th power. You could take this 3, move it up, raise 36 to the 3rd power, and then actually combine these two logs together. We would take that 6 to the 4th and then divide it by 36 to the 3rd power and make that one logarithm on the bottom. But that'd be as far as you can go. So this is the exact answer. Again, if you wanted to combine these here in the bottom, you could. However, we're asked to find both the exact and the approximate to the nearest hundredth. To type this in, we're going to do log of 36, remember to close that parenthesis, divided by, and then we have two terms here on the bottom, so we're going to need to use an extra set of parentheses. This will be 4 log 6, and then minus 3 log of 36, and then close them. So this is actually -1. If you want to, you can check this back in the equation. So I'll go ahead and box these in as our answers, but we could go back and substitute those in. One thing I like to do is I like to use whatever my answer was, and this is an interesting one where it happens to be -1, but especially if it's a decimal, then down here, what you want to do if it's a decimal is you want to try to keep that value that you have in your calculator. So I'll show you how to do this by just using the answer function that we kind of like we did before. So we're going to take 6 and we're going to raise that to the 4 times your answer. Then if we take this side and subtract the right side, if these are the same numbers, then we'll have one number minus itself, and that should be 0. So we can use that little trick here to keep the value that our calculator found as the answer, and we don't have to skip any steps. So this will be 3 times our answer from the previous step, then plus 1, and if we evaluate this, we should get 0. So if you take one side of an equation, subtract the right side, and as long as they're the same, you should get 0. This is a case where that happened, so that our answer of -1 does work.